Hey everybody, hope we're all having a good day. Sorry I can't be there again today, but hope to return pretty soon. All right, so what I wanted to do today, here's the agenda for today. First thing I'd like you to do is get out the homework, okay? The section 6.5 homework that you probably did mostly in class yesterday. It's that page 442 and 443. So we're gonna get that out and go over the homework key, and I'll go through all of the answers and just give you some pointers on things that I saw or things that I think you might want to watch out for. The next thing I want you to do is, if you have not already done so, check your grades. Make sure all of your grades are what they should be or what you think they should be. Make sure all of the assignments that you turned in are actually turned in. Just make sure, cross-check Canvas with Hack and make sure everything's good to go, because once it gets past this weekend, I can't really do anything more about your grades. And then third thing, make sure the sub should have the section 6.4 and 6.5 worksheet. It's also located in the Canvas assignment. So there's links to the PDF right there. Notice that you don't have to do all of the worksheet, though I've specified numbers for you on Canvas. Okay. So again, yeah, you may be watching this later, not in class, just because I know a lot of you guys had to take the AccuPlacer today. But yeah, so if whenever you're doing this, if you have any questions or anything, please feel free to send me a Canvas message. All right, so let's start to go over the homework. It's 16 to 20 even and 21 to 27 all. So for 16 here, notice that you remove the 4x as GCF, and then we're left with this x to the fourth minus 2x squared plus 1. Remember, I would say maybe introduce an a as an x squared. So that would be left with an a squared minus 2a plus 1, and then that's a little bit easier to factor. A minus 1, a minus 1, which is an x squared minus 1, x squared minus 1, which both of those are difference of squares. So you get a plus 1 minus 1, plus 1 minus 1. Don't forget, a common mistake is to forget about that 0 as one of the roots. Don't forget that 4x is set equal to 0. Well, you see it right there. 4x is equal to 0, and then you divide by 4, and you get one of the roots as a 0. Okay? So you have the roots of 0, -1, and 1. And just for good measure, because -1 is there twice, -1 would have a multiplicity of 1. And since +1 is there twice, +1 would have a multiplicity of 1 as well. Someone asked me that, when do you have to state the multiplicities? I will be specific when I want you to state the when I want you to state the multiplicities. Okay, I'll be very clear when I want you to state the multiplicities. In this case, I don't think the book asked you to, so you didn't need to. All right, here's 18. Okay, again, this one is where you'd add the 36 over to the other side, and then again, I would introduce a as x squared to be left with an a squared minus 12a plus 36. Factor that down. That's a minus 6, which you can then put back into x squared minus 6, x squared minus 6. Watch out, 6 is not a perfect square, so you basically just set those equal to 0. Okay, so you add the 6 over to the other side, and then square root it. Do not forget the plus or minus radical 6. Okay, plus or minus radical 6. Taking a look here at number 20. Now, number 20, this is a really, really, really bizarre way to solve this problem. I used to just kind of like blank this out, like take a white box and just blank this all out. But I've started showing, a couple years back, I started showing this method because I just think it's kind of interesting here. Take a look. Obviously, you would subtract the 6 over to the left side, and then you get this 4-term polynomial, and the only way we know how to factor that is by grouping, and it doesn't factor by grouping. But look at what the book did here. It took 7x and broke it as -4 and +11, or 7x squared, and broke it up as -4x squared and +11x squared. And the reason it did that is so that when we factored by a GCF here, you'd get an x minus 1, and then this factors into 11x plus 6, 11x minus 1. And look, I have a common factor of x minus 1. Both of these products have x minus 1 in it. And then you can remove that x minus 1, pull it out, and what's left over? 4x squared plus 11x plus 16, or plus 6, which also factors, which I don't know. I don't know if I'd ever be able to see that. That seems like a very odd thing to do. So what do you do if you can't see that? What do you do then? Well, you would exhaust your possibilities of factoring and then go to your calculator. So let's pull up our calculator here and let's plug in. Where would we plug in? Don't forget that you plug in right here. You solve it for 0, and then that's the function that you put into your calculator. You go into your y equals, and I've got 4x to the third plus 7x squared minus 5x, minus 5x minus 6. And I'm going to graph. And I see that it crosses at -2, and then it looks like it's just to the right of -1, and then it looks like it crosses at +1. Okay, so we could either use here +1 or -2. I don't want to use this fair fraction one because I'm not really sure what's going on there. So maybe +1 or -2. It looks like over here in the work I chose to do -2. So you plug in -2, you get 4x squared minus x minus 3. Remember, the -2 corresponds to an x plus 2. And at this point, that factors in -12 that I had to get to -1 or -4 and +3. And you see that it does indeed factor. So the solutions are x equals to -2, x equals +1, which we saw from the graph. And then I've got this weird one, -3/4. -3/4. Okay. Here is number 21 and 22. You can disregard this possible factors here. We'll talk about that later. It's the rational root theorem. You don't have to worry about that. So taking a look at 21, I remove an 8x squared, and we're left with this x to the third minus 24x squared plus 192x minus 512. This is another one of those funky factoring ones where like they're looking at it and somehow they see that that's a x minus 8, x minus 8, x minus 8. So what if you didn't see that? Well, you plug this into your calculator, and then you'd see that it crosses at 8, and it actually bends through at 8. So what I do here is I run it through, and then I see, oh, now this quadratic factors into x minus 8, x minus 8. So I get x equals 8 with a multiplicity of 3 because it's there 3 times, and then x equals 0 because the power is 2, x equals 0 with a multiplicity of 2. Okay, same thing for number 22. This does not factor, so I go into my calculator and I see that it crosses. Looks like it bends through. You know what? Let's just double check this. Let's graph this. So I've got y equals x to the fourth plus 2x to the third minus 11x squared minus 12x plus 36. And then I graph. Okay, it looks like it looks like it bounces at -3 and +2. Bounces at -3 and +2. So what does that mean? That means there's an even root at -3 and an even root at +2. I don't necessarily know the actual multiplicity. All I know is that it's even. Okay, so I can use at least 2 roots at +2, and I can use at least 2 roots at -3. So it looks like the book here is choosing to do 2 roots at +2. Okay, so I run +2 through synthetic division, and I get this left over. And then I say, okay, well, since it bounced, I know I can use it twice. And then I run it through synthetic division, and look, this is a factorable trinomial, x plus 3, x plus 3. So I've got x equals 2, and then x equals -3, both with a multiplicity of 2. All right, here's number 23. This is that volume of the box problem. So let x represent the side length of the cutout square. I believe it looked like this, right? Something like this. Yeah, something like that. So what we're going to do here is let this be that, right? So if I want to figure out what the volume is going to be, this little piece in here is going to be the height. So if I want to figure out length, width, and height, that little piece in there is going to be the height. So the height is going to be x. It looks like this was a 10, right, total. So it's 10 minus x for the length, or 10 minus 2x. The width, same thing. So it's 10 minus 2x. And now I multiply these 3 things together. X, 10 minus 2x, and x minus 10 minus 2x. And I know I want the volume to be 48, so I set it equal to 48. I multiply everything out on the left side. I set it equal to 48, and then I got to subtract it over in the end. And now where am I getting this 3? I get it from the graph. So if you need to, go ahead and verify it on the graph. You see that it does cross through at 3. And this is what I get left over, 4x squared minus 28x plus 16. Now at that point, I would want to plug this into the quadratic formula or something. Well, I guess I should put a lot before. But I want to plug it into the quadratic formula because this does not factor. Factors of 4 that I have to get to -7 do not exist. And now, so I plug it in the quadratic formula, or you could complete the square, but this is odd, so no thanks. Let's plug it in the quadratic formula, and this is what you would get. Now, these answers are irrational, so there's not a possibility of those being a solution because it's an actual concrete thing. So the only possible solution is our x equals 3. So the side length should be a rational number, so you got to cut out a 3 by 3 inch square. Okay. Here's number 24. Another one of those factoring problems. Just watch out here in the end. You get x minus 2x plus 2. This does not factor down anymore. You set that equal to 0. You get x squared plus 1. Well, it's right here. X squared plus 1 equals 0. You subtract the 1. You square root it. You get plus or minus I. So fully factored equation. Actually, these are the. Oh, it asks for the real roots. I would say if it asks for the roots here, it's -2, +2, plus or minus I. Right? But they were kind of funky there. They just asked for the real roots. I won't be that mean to you. Okay, here's 25. Looks like I can factor this one by grouping. So I've got an x squared minus 2 and a 3x plus 4. You set x squared minus 2 equal to 0. I don't know why they're plugging this into the quadratic formula. That's silly. Because you could just literally just solve for it. It's got no b term. So I square root the other side. You get plus or minus radical 2. I wouldn't really worry about this this factored part of it. I really just want the zeros here. So plus or minus radical 2. And then this 3x plus 4 gets us a -4/3. Okay, and here's 26. 26, I pull out the x squared. I'm left with an x squared minus 2x minus 2, and that does not factor, so I've got to plug it into the quadratic formula, or I could complete the square, but I think you guys like the quadratic formula better. The solution should be 1 plus or minus radical 3. Now, again, I wouldn't worry too much about this factored form. I'm really just worried about the roots right here. So x equals 0, and x equals 0 from this piece that we pulled out here, the GCF. X equals 0, and x equals 1 plus or minus radical 3. You don't have to worry about part A here, but there's the answers for part B, C, and D. Okay. All right. So again, folks, at this time, please go ahead and check your grades, make sure they are what they are. Send me messages if you need to, and then go ahead and work on that section 6.4, 6.5 worksheet. All right. Hope we're all having a good day. See you later.